There we go. So I was saying before, like, let's try to make it as interactive as possible. If you have any question, please feel free. The purpose of this application is to allow any user to record as many metadata as possible regarding the instrument that's been used for an acquisition and the acquisition itself. So as you can see here in the main screen, the app is basically divided in like manage the instrument and manage the acquisition, the settings. And here you can see the tier. That means basically which kind of, let's say, how many metadata you want to record about this session in this session. So the tier 1 means basically basic for materials and methods. Tier 2 is more for lifestyle acquisition, and tier 3 is like complete metadata of everything that you are doing. So we can start like going at tier 3 on the manage instrument. You can decide to start a new instrument from scratch, an inverted microscope, an upright microscope. For the moment is the only two we have. And then load from a file that you receive from someone else, or load from your repository, that in this case being a standalone version, you load from a folder on your local machine. And if we go here, it's trying to be a little bit intelligent about which kind of microscope you have. So we can go in a first view here, create inverted. This is how you, let me move windows around. So this is what you see when you arrive here. You're gonna have all your components that you can drag and drop into your canvas. You can see the canvas is pretty big, but let's say we start with a transmitted light source. There is a snap in place feature, so that allows you to basically build a microscope and have the slots for the components that you want to drag and drop. So here, for example, a fluorescence, here you have 6 slots for this kind of component. You can put it in. Once you have your component in, you can click on the component, and it gives you like a complete list of fields for this component, being general fields like how you want to call this component, a description, manufacturer specifications, and then more custom data about like this information, this component. So for example, in the case filament standard. So in this case, we are going at tier 3, so it requires to insert all the data that you can give. So whenever you try to confirm, it's going to tell you exactly you are missing this information about this component. So in this case, it's going to tell me I'm missing all the manufacturer spec. I can confirm. And here now you cannot see very well, but there is a green dot here that tells you like this component is being filled. So you can move to the next component in your microscope, in this case, this one. Again, we can go on confirm. And it's going to allow you to insert the information about this microscope. An additional thing is that you may want to have all the fields available, but you are not able to fill them all in this session. You can lower your validation tier here. So you basically can have a full list of components, but try to validate for a lower tier, and it requires basically to insert less information and still have a valid setup based on the model that we are using. Here you can see like general information about the microscope, in this case inverted. Here you can have export or save. Save basically saves on the local repository, in this case standalone version. Export allows you to save the microscope wherever you want. Let's go see something a little bit more complicated. For example, this is a full microscope that Katerina prepared. As you can see, there is a lot of information in here. Like this is a microscope that we have at UMass, and there are more lenses that can be swapped in. So we listed basically literally every component that. So I was just saying about this microscope is like, this is a full microscope. All the components have been created here. And in case you want to reuse this microscope for, but you're swapping a filter set or you're swapping a lens, you can just drag out the component that you don't want to use and drag in the component you want to use for this session, for example. This is extremely interesting from our point of view because it allows you to save the information once regarding the microscope and then reuse it every time that you are doing an acquisition. So you don't need to continuously like rewrite the information, for example, in an Excel spreadsheet or something like that. You can just like save it once and then reuse it for all the acquisition. And how do you reuse it for the acquisition? You can go in here. I can select tier 3 in this case. You select manage settings. In this case, we're gonna pick again the microscope that we were using before. And then here is allows you to load the image that you acquired using this microscope. Now this part uses the OME bioformats libraries to pull out as much information as we can from the image file. Now let's say we're doing a settings from scratch. Now here, like I'm using the microscope from before. I loaded the image and you can see like I'm already pulling out the channels from the image, from the metadata from the image. Now you can go in one of these, in one of these channels, for example, and then you can see like, okay, which light source I use for this channel. Because the information was not available in the metadata, you can select your light source. This is coming from the microscope that you are reusing now. This tell you this light source has this specification. You can click it, and then it allows you to say, okay, what were the settings specific for this acquisition for this light source? You can put in your illumination power settings and so on and so forth. Again, same validation system as before. And here you can build your whole channel as you want. In this case, we have like some slots here, like add additional elements. You can go in and you can say like, okay, there were like these many components lined up in this channel. You can see these components that are grayed out because they require no settings or they have no settings that you can select. But this component, for example, has mirror device settings as an angle that the mounting angle of the component. Now, the same thing is valid for planes. In this case, there was no information about planes coming from the image, but you can add your own planes or add multiple planes at the same time based on standard increase in one of the dimension that you have available. You can select your environment and control. And here have the settings if there are. Here, add. Here have the settings if there are. You can select the table. Again, same structure. It's basically everything is graphical. You go in, you add your component, and then it is available on the top line to insert the settings for this component for the image acquisition settings. Same concept for the objective. Now the objective behaves a little bit different because you can set the objective here in the main view, and then every channel is automatically inheriting the objective that you're being using for this acquisition. All this data that you see in the fields is based on the model that BINA and 4DN initiative are producing. And basically, it's automatically populated from the model. So the model comes in, it gets downloaded from the GitHub repository that we are using right now. So it's not like extremely static. And the model is based obviously on the OME model as a source. So you can open you can see here there are all the files as attachments on the project on OME, and you can open the. Let me close this. Restart here. You can open the app here. You can go as before, like the repository. What changes here is the repository, instead of being pointed to your local folder on your computer, is pointed to the project folder on the OME server. And now you can see all the microscopes are listed that are found in that specific project. From here, obviously, we want to expand more and go to a point where like you can actually have maybe a picture of the microscope we generated in the previous canvas in the OME server as an image, so that they are browsable, and then being able to connect them directly to the image in OME. And obviously, the next step here is being able to do the same procedure that we're doing in the standalone version, retrieving the metadata from the image, doing the same procedure on the OME server. So doing the bindings for retrieving those metadata from the image from the server. And that's it. So if you have any question, or if you something that you want me to repeat, feel free.
So yeah, this is great to capture all this metadata, but in terms of the general workflow that people will do, at which stage do you think them doing that? Because obviously that's quite involved in terms of the amount of data you need to capture.
So the general idea would be that if you have a facility manager that handles the microscope, or if in general a laboratory that have their own microscope, they should do the part of manage instrument once when they set up their microscope. Or worst case scenario, if they have an update, I don't know, how many times do you go and actually change your microscope? Like how many times do you install new components on a microscope or change your components on a microscope? So that should be do like once or couple of times per year tops. And the acquisition part, obviously, it's every time you do an acquisition. So once you have done your acquisition, you should be able to import the microscope that you used, import the images you used, and then enter the information that are missing from the image. And this is like in a perfect world, all this information should come from your image already. So you shouldn't really be required to add anything. Because as we well know, that's not the case right now. Hopefully it's going to be the case in the future, but for the moment, there is a lot of information in the acquisition still missing. So that step should be done like, in an optimistic case, every time you get an acquisition.
So, question from Matthew, and then there's another question from in the chat. So Matthew, go ahead, please.
What sort of output format do you get from this? Can you
everything is JSON.
Right.
JSON files. So it's human readable, and human readable in case you compact it, because otherwise it is a lot of information when you have 200 planes. But and it's usable from every other any other web services in case. So it should be easy to actually import it or and handle the data in whichever way you prefer.
Yeah, so integrating with bits of other metadata schemas should work well.
Yep.
Brilliant. Thank you.
There's a question in the chat, Alex, from Asta. Sorry if I don't pronounce correctly. Is there a quick way to check manually and if the metadata is correct, considering it is manually added, like maybe a quick browse?
So. Can you try to explain a little bit better what you mean?
Asta, could you speak?
Do you hear me now?
Yes, yes.
So I mean, it's because it's information that you're adding, right? I mean, it's not really coming from a source that's not mutable. Like you can change it. So there must be. Is there a way to then check if the information is correct? It's almost like you're always manually adding this, so you might want to always manually check it. I mean, maybe I'm missing something.
I mean, like it's the same concept of like most of the people that I know nowadays have this Excel spreadsheet to record all this information. It's still information that you are adding manually. It would be nice in a second, in a following development cycle, to be able to create dictionaries of values that one field can be filled with. For the moment, we have some dictionaries of some fields. You saw that there are some fields that are drop-down menu. But the other information is like numbers, for example. If the number doesn't come up from the metadata, there is no really other ways of retrieving the data. Again, like the part of the instrument should be checked by whoever is in charge of the microscope. So they can go check the specification of the microscope and be sure that those are the values that are in the microscope currently. But apart from the acquisition settings, it's whoever is running the acquisition is the one doing the work of changing stuff. So he should be able to insert the data of his own acquisition. I hope that answered to your question. Nikki?
So you mentioned that, say, a co-facility manager would go in and input all the information for the instruments that they would have, so that users would essentially just pick and choose what instruments they're using, and all of the components and everything would be in that system already. How accessible is all of that information? So if, for example, you were interested in setting up a database of all the facilities in the United States and all the different instruments they had, if they had used this system to input their information, how would that information, you mentioned JSON files, are those files that could be accessed so that you could build essentially a database of all the instruments that were in a particular continent or something like that?
Again, in a perfect world, the best solution would be that every component should be recorded in your database. So once you record one component with our app in this case, or whichever app that allows you to write a JSON file following a standard, that component should be saved in a database. And then the database could be accessed directly from the app, being like, okay, I'm adding a light source. The light source is this manufacturer, this model. Here, the standard, it's already written. So here, your light source. And the database serve your light source. At this point, we are still in like an early phase. So it's like the database still needs to be made and filled. So, but yeah, like ideally, like it wouldn't be that difficult to go from here to, okay, let's build a database of all the components if everyone is collaborating, kind of thing. Yeah, Jean-Marie?
Yeah, you mentioned Excel spreadsheet earlier on, so people record that in Excel spreadsheet. Does the tool allow to take Excel spreadsheet and convert them, or what will be the process that if people have already spent hours and hours entering that in Excel spreadsheet, do they have to redo it? Or
so for the moment, we have a similar system for the OME metadata that we are pulling in. We have a linking table that links basically one of field from our model to one of the field from the OME metadata model. And that allows to import the data and put it in the correct field. We don't have anything for the Excel spreadsheet yet, but like using the same system, it wouldn't be too difficult to actually make a mapping of, okay, this field that you have saved with this name, it's in reality this name in the model. So when you import the information, put it in there, kind of thing. Obviously, it requires to have again another dictionary, because it's like everything is like everyone uses field naming convention they want, and that's one of the big problem, and that's why there is this effort from the B940N initiative to actually create something that is a little bit more unified, at least a tentative of unification. Is there anyone? Oh,
yeah,
Jean-Marie again.
I've got another question. This
Sure.
is more practical and technical here, because I was checking its Electron app. So what you show was more what you showed today. Do you envision, if you choose Electron, do you envision to have a web app as well, an extension either?
So it's already like that. So basically there is a web app that is the core plugin, let's say. And there is an Electron app that wraps the core plugin. And that's for the standalone version. And then there is an Omero plugin that wraps the core plugin. And that's what we put in our Omero server.
I see.
So it's completely modular, so that, for example, the 4DN Nucleum initiative has a portal that is called 4DN Portal, and they are trying to integrate this plugin right now. So they use just the core version, and they wrap it in their own way to make it interacting with their own database. Yes, Matthew.
How many people do you have using it at the moment, particularly people on the more experimental end?
So we have, I think, 12 for the paper that we are trying to publish right now. We have 12 laboratories doing test cases, and like apart from some initial bumps and still bugs in the app, obviously, we got like 12 microscopes with 12 image acquisition settings from 12 different images. And it was interesting. It was a nice test case because it's like some images that were like thousands of planes. And then you realize, like, how would you record thousands of planes if you cannot pull the metadata directly from the image?
Yes, no, very familiar with that problem.
So we have another like we have another two labs that are helping us with testing the Omero plugin a little bit. But again, like you saw, it's very early stages. Like there is no permission yet regarding like which user is logged in. Every user can see each other microscope kind of thing, or each other image acquisition settings. But yeah, we are trying to like push the development on that side. And first step will be like creating more different kind of microscopes still, because we're still missing like the advanced and confocal part of the model. I mean, the model is there, but we're missing the integration of the model in the app kind of thing, because it requires a little bit of fine tuning. You're very welcome.
So sorry, just a side comment. So in the long run, you could see that as almost, let's say I've put my images in Omero and you know which microscope has been linked of quality control. If there's a failure in your microscope at some point, you know this is a Leica whatever, and the objective was used. Okay.
So in my perfect world, whenever you load an image on Omero, you could already like select from Omero directly which microscope you used, and load the image. It extrapolates the metadata already, and during the uploading phase, you get already asked, like, okay, add this more metadata because they are missing. So that would be like my perfect world. Obviously, still a couple of years away at least, but like it would be very good in my opinion to have something that automatically tells you like, oh, you're missing this many metadata if you want this level of standardization.
Thanks, Alex. It was great. So you might have to stop the recording before you get kicked out of the. You only have 40 seconds to do so.